Again, welcome to this webinar. My name is Janssen. I'm CEO, co-founder of Sofar Ocean. I'm very excited about this discussion today. I love the topic. Just great technology, and I think an incredible opportunity for the industry and is decarbonization efforts. I'm also incredibly excited to do this together today with Paolo Tonon from Berge Bulk. And Paolo, maybe just to kick it off, can you give a little bit of background about yourself and Berge Bulk, and in the context of this discussion?
Perfect. Thank you, Tim, and thank you for inviting Berge Bulk and myself, and good morning and evening to all the participants. I'm Paolo. I'm the technical director in the company, which basically means I'm in charge for all the technical management of the own fleet of Berge Bulk, including all the new building, innovation, decarbonization, and retrofitting of technology on our vessels. A little bit about Berge Bulk to start with. Berge Bulk is a privately owned company, founded by our CEO, James Marshall. And today, Berge Bulk, if we can go to the next picture, is a company where we own and operate roughly 90 vessels. Vast majority is owned and operated in-house, totaling 15 million plus deadweight tons. So most of our vessels are large vessels, VLOC, Capes and Newcastle Maxis, and we have a small portion of handy-size vessel in a differentiation strategy that in Berge Bulk we used to call from mining to dining, with a completely differentiated cargo type. Looking a little bit of last year, as Berge Bulk, we sailed for roughly 5 million nautical miles, and we transported more than 70 million tons of cargo. Give just an impression, good 75 to 80% of that cargo is iron ore. And probably we have a few attendees from US, from California. With that cargo we have transported, with that iron ore, you could build more than 500 Golden Gate bridges with the amount of steel you can produce from the iron ore we have transported last year. 2,500 employees, vast majority are our seafarers on board of our vessels, and we have truly a global pattern. Probably that next picture would explain that. So we are into the major trades for the dry bulk shipping, especially for the iron ore, from Brazil to China, from Australia to China, from West Africa to China, and then we have our other vessels bringing the other commodities, tramping all over the different seas. So, and as such, as a private-owned company, we have ranked now to the second largest company in the world in dry bulk. So it's quite of an accomplishment for a company that is only 18 years old.
Great. That's incredible. I'm glad to know that if we ever need to replace the Golden Gate Bridge that we have, there's enough steel to go around to do that.
Absolutely.
Thank you for sharing. So on our side, just to give a little bit more context on the Sofar side, like who we are, what we do. As Paolo hinted at, we're based in San Francisco. We're headquartered here. We are a marine weather intelligence company. So our focus is entirely on improving marine weather forecast and use that to the benefit of industries that operate in it, like maritime shipping. So we are headquartered here in San Francisco. We're globally distributed to basically deploy sensors worldwide, improve forecasts, and deliver route optimization and voyage optimization to our global fleet of Wayfinder users. As you can see on the spinning globe, this shows you the world, which is mostly ocean, And the yellow dots are our sensors that are delivering data back to our backend every day to improve the forecast across the world's oceans. And so the challenge with optimization and voyage optimization in many ways, and this goes across the board for most any sort of like optimization problem, is usually not the optimization itself. It's actually the information that you put into it. And the outcome is only as good as the information you put into it. And so to reduce weather uncertainty, which is one of the key parts of that goes into like voyage optimization in the ocean, the only way to do that is to measure. And we take that very literally. We built networks of sensors that we deploy from airplanes and ships across the world. And you can see one here in this picture. It's basically a solar-powered, satellite-connected sensor that measures everything weather-related on the surface of the ocean. We get updates from it. We build very large networks of these. This is a snapshot of our current network across the world. This is by far the largest ocean sensing capability in the world. That then is driving our forecasts internally. So this process is called data assimilation. We take all the data from these sensors and we kick off our own forecast simulations in the cloud here in San Francisco. And that forecast is then used to help ships find more efficient routes across the ocean. And so really what this is basically translating an information advantage into a business advantage. And so there are three buckets we see as like important for optimization. First, to understand what voyage optimization is, to our mind, is finding the best possible opportunity in an opportunity space which is set up by the vessel performance, the weather that it encounters, and the market that it's operating in. Those are given. I mean, basically, we can't really change them. The only thing that we can do is find the best opportunity for this particular vessel at this specific time in this specific location and do that dynamically. And so there's three components to that we think are really important. One is the weather itself, which is the friction field of the vessel. Obviously, you want to know that pretty well. Second, the vessel performance models, so the relationship between what the vessel is doing and the environment it encounters. And thirdly, sort of like more on the parts of the optimization itself is that we have to dynamically update this optimization always because the world's continually changing, weather, market, and vessel performance. So this has to be a dynamic system that is also easily accessible for both shoreside and vessel side in real time. And so this actually works as sort of like as a stepping stone technology. I mean, we've had several of our partners and customers go public with sort of the results that they've seen, and savings around like 4 to 6% can be achieved. And obviously, this is a stepping stone technology in terms of a journey for decarbonization. It is sort of like, I think, a starting point where on top of which we can then start thinking about like how can we integrate other technologies into the optimization strategy and use those new technologies really well. And so that brings us, at least to some extent, to sales, because what I think is really exciting about sailing technologies is that it is a completely new technology that helps decarbonization. Obviously, in a very large extent, like we can use a renewable energy source to drive the vessel forward. It's also a new technology. It's got an incredible upside, but I'm sure also like real challenges from a operational perspective. Like how do you incorporate that into the overall strategy of the company? So Paolo, I'm really curious, like how do you see sort of like sales and sail technology fit into the strategy for Berge Bulk now and in the future?
Yeah, sure. Thanks, Tim. I think no doubt that in Berge Bulk we are a believer of the wind-assisted propulsion. We have made a number of investments. Actually, we have two ships with wind-assisted propulsion, one with rigid wings on my that I use as a background, Berge Olympus, a new Castelmax vessel sailing between Brazil and China. We have another VLOC, Berge Neblina, with flattened rotors, and a second vessel with flattened rotor will soon be sailing in the sea. And in the past, we have also tried kites, and and really study that technology. Let me go one step back first and saying that wind assisted propulsion, normally the producer of those technologies, they are approaching you with a set of thrust curves, and that's based on the specific technology that they sell. Our role in Berge Bulk is to translate the thrust curve into tons of fuel that we can save. And it's obviously not an unknown path on how to do it, but the complexity, as you say, Tim, about operation is really what makes this exercise extremely important. We are having with the specific trade she's sailing into. Obviously, wind-assisted propulsion is creating an additional drag to do the leeway of the vessel, and that needs to be accounted properly. Similarly, the main engine, when you have wind-assisted propulsion, start to work in a completely different operational window, and that also has to be taken into account. And I think this is something that we have been really working, and we have the view from the different technologies. And I think what we are doing in Berge Bulk, we are trying to build really a standard methodology on how to evaluate the effect of wind-assisted propulsion technologies on the vessel. And the merge we are having with the Sofar product is really fundamental in doing so, because it gives us transparency, it gives us better understanding on hull performances, on the state of the sea, and how all these things interact, and therefore we can evaluate much better the benefit of those technologies on the vessels. I think this is quite of an achievement, because only when you use those technology you can walk this path. Otherwise, you remain with the brochure numbers that every maker is having.
Yeah. Yeah, I can imagine. Like it's always a difference between like a real life, like operational condition, even if the technology is as it is advertised. I mean, you're operating it in an environment where basically you're not necessarily a priori know that the wind is going to be exactly perfect for these sails, and what in a sort of like realistic situation when the goal is to maximize the earnings of the ship, like how much in that strategy can sales contribute, right? I mean, that is, I think, just an
Absolutely,
operational challenge.
absolutely, and I think it went pretty much in the past years when we started our collaboration, really to get inspired on your way, as you introduced before, on your way to understand sea state, to understand weather. And I think there is quite of a joint effort between our two companies in creating value on top of value, right?
Yeah, absolutely. And I think this is also goes back to, I think, our partnership over time. I think as long as we've worked together over the last couple of years, a lot of the product development on Wayfinder has had incredible benefit of working with your fleet. And I think that has just extended, with sort of like the sailing ship. So we've worked together, we deployed Wayfinder across your entire fleet. And since recently, now also the sort of like wind assisted vessels, which again, something that we jointly could work together on in terms of like understanding not only like how do we incorporate it into optimization, but how do we calculate the ROIs, for the company, and what are sort of like the dependencies there, and how to get better at it. Like for instance, like the vessel performance model itself will be impacted by the fact that there are sales, not only from a thrust perspective, but also like to your point, you're basically running the propeller now in a different environment because you have something else is propelling the ship apart from the propeller. And those are all, I think, things that from the data and from sort of like having a workflow that real time assimilates that data into like a vessel performance model and an optimization system, you can learn a lot. And that learning is something I think that we're now in the middle of, right? Like figuring out like, okay, well, what are the impacts and how do we quantify that in terms of like, overall impact on the business? And also like, how do we optimize it to maximize benefits and minimize potential, drawbacks.
Absolutely, absolutely. So, and I think over there you said it very well on how Wayfinder is really melting and merging together with our needs. Um, is there anything specific that you have as a company learned when incorporating your product with wind assisted propulsion?
Yeah, I think we've learned a lot, and we continue to learn. I think the first step is just sort of like stepping back a little bit on like how you know how does sort of like optimization really works. Basically, what we're trying to figure out is like what's the best strategy for the vessel in sort of like market vessel and weather space, essentially. Um, and the first step is then onboarding a vessel, which means that we need to understand its performance. We need to understand what kind of vessel it is. Like, we start with like high level physics, um, relationships based on like the shape, the form factor, the kind of propeller, the kind of propulsion. And then it becomes a data-driven problem, right? So we actually either take historical data if available, but always in real time, we're basically taking information from the ship to adjust basically its performance to make sure that whatever we think happens in the future, because that vessel performance model is going to help us figure out like what the cost of each strategy is in terms of like the time spent on the water and the fuel consumed, that's going to be a really accurate representation. So the first step that we do in sort of like incorporating sales is to modify that vessel performance model. In fact, that is technically also the last step, because once we've modified the vessel performance model, the optimization problem is the same. Like basically, if you have a good representation of the vessel, and in this case now you have a vessel with sails, then the minimization of a cost function remains the same. And you're basically still trying to figure out like what is the most economically effective strategy for this vessel now that it has sails. Now, on the specifics of changing that vessel performance model, there is on the one hand, obviously, you start with some like notion of a thrust curve for the sails. You incorporate that as sort of like an initial guess for how this sort of like sail is going to perform. And then you use the data coming from the vessel to basically morph that into like a complete performance model, including the sails, where the sail thrust is actually adjusted to what we actually notice as a change in the vessel performance model. So it becomes like a data-driven system where basically just the initial condition of that system, so the ship, is modified to incorporate for the fact that we now have sails, and an initial guess would be like the thrust functions or the thrust curves that the manufacturer provides. And with that, basically, we can then create a new vessel performance model. I think the learnings there are, one is how good it works in the sense that, for instance, we did a simple trial when we just changed the vessel performance model for a large vessel to see like what would happen if you would steer it into the wind, and it would start making tacking like motions like a sailboat in many ways. And this is obviously not a sailboat; it doesn't have a keel like it. But it was interesting to see that basically the whole system automatically adapts, to the fact that now we have wind-driven propulsion on the ship. The other learnings that we have, and this goes back to like your earlier comment around like the impact on the behavior of the ship itself, is that sails do add other forces on the ship. Like for instance, your lateral component of
Yep.
force is going to also increase, and that could actually lead to drift. It could also change the slip on the propeller, and so those are things that I think we're seeing now in terms of like, okay, this is noticeable and visible in our data, and it impacts the vessel performance model also in those ways. So trying to parse out like what that is and how big that is and like how that sort of like can be incorporated into like the ROI estimate. This is, I think, an ongoing discussion between your team and ours to like figure out like how we can best capture that.
Absolutely. Absolutely. Yeah.
Yeah,
Very important.
it is. And so I'd love to hear like the way I look at sort of like sales and sales optimization is that it's sort of like this, we have a stepping stone technology, which is like optimization, which is sort of a no-brainer because it costs almost nothing. Every major logistics industry in the world uses it to like just get more efficiency out of the thing that you already have. Now we're adding sales, which is like, I think the right step. Like you first have optimization, then you add new technologies. How does sail technology fit into like the broader, I would say decarbonization strategy that Berge Bulk is sort of like deploying? It is one of the things I'm sure. I mean, we see this across the industry. what other things are you sort of like working on, and how does sort of like sail propulsion fit into that?
Yeah. So I would say still remaining a bit on the wind propulsion. Um, that the moment you have introduced such a stepping stone, such a big change on the vessel, the way you have been optimizing main engine, the way you have been looking at hull, they becomes also different. So
Yeah.
we have had the need to go back to the optimization, sub-optimization tools that we have for propeller, hull, and engines, and also revise how we really look at those things. And at a certain point, priorities also change in the energy efficiency chain on a vessel, because you have such a different element into it. Um, going back to the decarbonization in Berge Bulk, I think our owner has launched some time ago the Maritime Marshall Plan, obviously saying decarbonization is a war. We are all in, and we need a plan. And our plan is based on four pillars. Pillar number one is really optimizing the vessel. There is no point to make the investments we are discussing if your hull is green or if your propeller is fault. So you really have to take care of your asset. You really need to understand how you can squeeze out every gram of fuel, because a non-burn fuel is the real saving. So that is a continuous focus in the operations, getting the right trimming, getting the right ballast, and optimizing the vessel for the mission. That's number one. I think over the years with that one and the second one, which is implementing technologies, and we go from the standard one, like a Mewis duct around the propeller or a propeller boss cap fin, or the utilization of more sophisticated paint schemes. I think Berge Bulk have been able, baseline 2020, to reduce the annual efficiency ratio of 48%. So we are well ahead of the curve, and that's a mix between also having younger tonnage in the fleet in between, which is by definition coming at an higher efficiency compared to the past. But it's without that one, I would say there is no sense to look into technologies like wind assisted propulsion. We have been implementing solar panels on some of our vessels. We have air lubrication, and we have shaft generators. I think we are the first one in a dry bulk segment to retrofit sizable shaft generators, megawatt shaft generators. So we have 5 vessels with that technology, and I think it's the combination of all of those that is really bringing us down. Then we go to pillar number 3. Decarbonization will only happen when we have alternative fuels. And we have been very much looking into, and we are running with biofuel B100. We are ready to start whenever the market will be ready with the methanol vessel. We have ordered in an ammonia dual fuel ship. So delivery will be in 2028, 2 new Castlemaxes, and we are busy in detailing the last elements of the dual fuel system, which will be an ammonia dual fuel system. And the last pillar, the fourth pillar of our strategy, is carbon capturing and carbon offsetting. So we are the first company in the dry bulk segment that has offered carbon offsetting voyages to our customers. By the end of 2025, so the end of this year, in few months from now, Berge Bulk will be carbon neutral with the fleet. So we will offset with high grade certified program the entire emission of the fleet. That's one of the milestones that as a company we want to achieve. Second milestone is that before 2030 we will have a zero carbon vessel in the water, and that's our ammonia new builds. And then obviously by 2050 we will have a zero carbon fleet. So it's a massive program, and it starts again from what each and every company should master even more. That is the day-to-day optimization. And I'm saying again, given that the future will be on alternative fuels, and we all know the massive economical impact in the day-to-day operation of green fuels. If you don't have energy efficiency technology on the vessels, if you don't master them, if you don't optimize your vessel, you are condemned to very low margin, if not negative margins. So
Yeah.
what we are doing now is a really important preparation for the future.
Yeah. So in many ways, I mean, you're leading with this, which is for a company always a risky thing to do, right? I mean, you're taking bets and taking risks, maybe sooner than you're forced to do. I mean, you're choosing to do so. Um, but I think on the other side, and this I think goes to your point, is like, look, you're doing all the things now because you're anticipating that future. If that future happens, which we all assume that it will, you're going to be better prepared because in a world where fuel is going to be much more expensive, you will already have done all the sort of like pre-work to make the fleet as efficiently as possible. And so if you think about this for buckets, like where do you see sort of like the biggest sort of like immediate challenges today from a technical perspective? Obviously there's like the infrastructural challenges on like alternative fuels. There's also
Yeah,
like optimization challenges. There's new
yeah.
technologies. Yeah,
I think technologies will be available. Technology
yeah,
will be ready. Technology will be reliable. I think the challenge we have as a ship owners, ship operators, is to get our crew on board with those technology. It's a massive effort
interesting.
to really secure that we have well prepared crew members that can understand the technology, can operate in a safely manner all the different technology we put on the vessel. Because
Yeah,
the first and foremost, safety is of paramount importance for all of us, and we
yeah,
can't take any step that will increase the risk for safe operations on board of our vessel. So the preparation, how do we really engage seafarer, the amount of investments that needs to happen in with the seafarer is one of the probably is the biggest barrier that a ship operator, ship owner we have to tackle, because again industry will develop the right technology, and they will
yeah.
develop it at the right cost and with the right performances. That is no doubt. In the future, we will have infrastructure of fuel. It might take really still a while, but will our seafarer capable to run dual fuel in vessels? The amount of seafarers that today in the world are running dual fuel engines, it's very limited.
Yeah.
And we have we are in a war also with seafarers in terms of the finding the right seafarers and finding seafarers. Seafaring is not anymore a profession that is very popular in a lot of countries. So we will also have a problem in the merchant marine. In our industry, we will have a program to find resources, and at the same time, we need to upskill them on a level that has no there is no precedent comparison to be made. So these I think it's one of the challenges when I'm looking at carbon capturing. Obviously, the other challenge is to create a truly transparent and regulated circular economy for
Yeah.
CO2. And the
Yeah.
challenge there is that shipping has to enter into dialogue with other industry that are governed by different rules and
Yeah.
regulations. And unfortunately, we all hear what is happening right now in London with IMO and the different wish and political needs of different countries. So it's a complex thing. So while as an owner we have the problem with we have the not the problem, we have the challenge of training and upskilling our workforce. I think we need also to work all together as an industry to create the level playing field from a regulatory aspects that will allow those new fuels and technology to play a game, a fair game with the existing design of vessels.
Cool. So basically, the problem goes from like hyper local to like truly global. Um,
Absolutely.
on the one hand, the assets are getting more complex, and you need to basically very rapidly, get the operators on the vessel to like being able to effectively operate it. Like operating is one thing, but you have to operate it now in the right way, to maximize basically the benefits of the technology that's installed. And then secondarily, which is an obvious sort of like global problem, around regulations around decarbonization to level the playing field. But also just sort of like infrastructural development around alternative fuels. It's not just regulatory, but it's also like a technical challenge around like, a chicken and egg problem. Like if nobody's
Absolutely.
buying it, nobody's producing it, and we need somebody to produce it, but then we need somebody to buy it. And so so you don't see the challenges necessarily on the technical side, like those things will evolve, etc. But these are really the two things that you as a
Ab-
as a as a, as a
yeah,
sort of like
yeah,
company are
yeah.
primarily focused on.
Absolutely, absolutely. I mean, obviously, if we don't, from a regulatory aspects, and again in shipping now, we are all looking at London in this week with the
Yeah,
MEPC meeting going on. If we don't create the level playing field, there is no way that you can start bunkering a fuel which is 4 or 5 times more expensive
yeah,
than the today MGO or HFO you are bunkering.
yeah,
You and actually there is no way that a single player in the supply chain can absorb those costs. So we need also to find a mechanism on how those costs gets spread over
yeah.
the supply chain.
Yeah. Well, ultimately, whoever received the goods, which is all of us, will
Ah,
eventually have to pay for it. Um,
yeah,
but yeah,
sure,
obviously
yes, for sure.
yeah, those are big challenges, obviously on the regulatory field, and we're all looking for like change there. I think that's going to help move things
Yeah.
forward.
But
Um,
I
yeah,
think, Tim, let me, I think I really go back to one of the fundamentals of all these complex picture that we have just described, and that's optimization.
yeah,
And I mean, I think we all need to become much more skilled in understanding how do we optimize our assets.
yeah. And that's
And
a ch
and
yeah.
and I guess
What do
I,
you
I
see?
think
What do you see? What do you see as a challenge there? Like, what is sort of like the when you think about the optimization? What do you see as like maybe the internal or just technical challenges? Like, what do you see as sort of like the main hurdle there?
I mean, optimization is based on data, right?
Yeah,
So if you have
that is
data,
a hurdle.
you you can analyze it. You can understand if it's good data or bad data. Keep the good
Yeah,
data, analyze it, and create your own strategies on how to optimize. I mean, look at the world fleet. How many vessels really becoming digital?
yeah.
It's a small fraction.
Slow
So
process.
we,
Yep.
we, we, we are still working in this industry with wrong data or no data, wrong assumptions.
Yeah.
So I think we have done massive steps in this industry to optimize, but the next step can happen only if we have the right data available.
Yep. I think there's maybe also another layer to this. Like, I fully adhere to this data paradigm around like we have to have better data. The future is data driven. If you don't have good data, you can't really optimize. It's just that simple. Um, I think gradually that's starting to like seep in. I think there's definitely sort of like changes going on in the industry, but it's also understandable that there is some inertia, because it is also a chicken and egg problem. If there isn't a way to create value from the data, then there's also no incentive to invest in, say, a mass flow meter or another sensor to like improve your
Yeah,
ability to understand what the vessel is doing. So it requires, an optimization system that can make the economics better if you feed it better data, because then now that mass flow meter, you're going to earn that back in 2 weeks, versus it's just an expense, right? And so I think that the presence of like and the notion of that, if you learn how to do optimization properly and you make it better by adding data, um, you can actually make money on that and you can create a more efficient fleet without major capex investments. And that's pretty exciting. I think one other thing that I have seen, working with all different types of companies, is that proper optimization is a combination, like again, that space between weather, market, and vessel. And typically, most organizations are built around different parts of that. Like the vessel part is vessel performance. That's like the technical part of the company. The market part and the commercial part is done by a different part of the company. And so that has to come together. The notion of like, what does it mean to optimize a vessel has all these components, and the technical, the performance of the vessel has to work together with understanding like
Yeah,
how to strategize in the market, um, given the weather information that we have, to basically make sure that it is actual an economic optimization and not just sort of like avoiding heavy weather or pure safety or something else. It has to be all of those things together, and obviously safety being number one and the overruling factor. Um, and I can see that that is also like a cultural shift, because without optimization, you could think about those things more as like independent. But if you're really thinking about like how do I run my fleet more efficiently, economically, then they can't be. They have to ultimately
absolutely.
sit on the same table and think through like, well, if you make this investment to make the performance X better, how can we turn that into like actually a better strategy for this vessel, and how do we make sure that we have the systems in place to translate that? Um, so yeah, I think those are like major
Yeah.
challenges. That one is like the continuous need for data, and the second part is like acknowledging that voyage optimization is not just driving through weather a little bit safer, but really tying it to the economics of the vessel and thus the performance of the vessel.
And I think it's very interesting because the same you can see it and observe it from a regulatory landscape viewpoint. If you
Yeah,
think about what's happening in European Union with the EU ETS and the this year launched Fuel EU Maritime,
yeah,
those rules are really forcing technical and commercial to really work together.
yeah,
So it's not only a profit optimization of for the asset and a return of the
totally.
investment. It's also, the fact that the rules and the regulations that we have will force us to work better. And a company like Berge Bulk with in-house technical management and the commercial desks is I think we are well positioned to really tackle that and solve that equation in the proper manner.
Yeah, and that's obviously, I mean, again, I think the disconnect between those different components of the problem um, is realized in different ways. Like in a company like Berge Bulk, I mean, you're all in the same spot, but if you start like breaking up technical management and commercial management of the ship, then that becomes obviously a lot harder. And at least the awareness around the fact that for the best results, you can't really decouple those two, is probably it's a relatively new thing, because um, if you're not economically optimized, like really truly do optimization, then you probably won't have that problem. And now in the presence of like new legislation, that becomes even more urgent, because there is no way to get around that anymore. If you want to minimize the cost or the impact of legislation, then that should be inherent part of that same optimization problem. And now you're back to like, okay, we need to couple performance, technical performance, and economic performance or
Yeah,
commercial performance together, because they're part of the same, well, I would say opportunity rather than problem.
absolutely. Well said.
Yeah, great. I forgot to mention this for everybody who's listening in. We have a Q&A, and I hope you've all been dropping questions in the Q&A. Brandon will join us in a minute to facilitate that and go through the questions that came in from the online folks. And then, Paulo and myself will try to answer them as best as we can. So, Brandon, are you ready?
Yes, excellent. Thank you, Tim. Thank you, Paolo. It was a very interesting discussion. Hey, everyone. As Tim mentioned, my name is Brendan. I'm on the Sofar Ocean team, and I'll be guiding us through the Q&A portion of today's webinar. Before we kick off, as Tim mentioned, a quick reminder, please continue to submit questions while the Q&A is in progress. We'll answer as many of them as we can in the next 10 minutes or so. We have plenty of great ones to choose from, so I will waste no more time. We'll jump right in. Okay, so first question is for Tim. This is a spotter network question. So how does the data collected by the spotter network enhance Wayfinder's ability to identify routes with favorable wind conditions?
Yeah, great question. So the network of sensors provides a snapshot in real time of the conditions in the ocean, both wind, waves, currents, water temperature, and barometric pressure. That data is then used to basically enhance the forecast. So a forecast you can think of basically, you take an initial condition of the world state and you propagate that forward in space and time. And so what the data from the network does is, improve that estimate of what the initial state is, like what is happening right now, and then propagate that forward. So like with every other model, and this goes back to the data-driven, problems that we talked about in this discussion, your answer is only going to be as good as the data you put into. And this goes the same for like weather forecasting or vessel performance modeling. And so once we insert the data into our forecast, the forecasts become more skillful. So that means you're reducing the uncertainty of the weather forecast. And now you basically tie that to the optimization algorithm that understands the vessel performance, understands the sail performance, and you basically find a better strategy for that vessel based on the improvements in the weather condition. So if you're thinking about like the two worlds that we're putting together, it's the ocean environment that we're operating in and the vessel that is basically operating in it. And so by improving the estimate of like what happens around the vessel in both now and the future state, so basically the weather it's going to encounter in 2 or 3 or 4 days and beyond, we can find strategies that are just more skillful than one that if the forecast was more uncertain, or basically whatever our estimate was would also carry more uncertainty in being correct. So it's basically the same as anywhere else in the system. More data means lower uncertainty, means greater fidelity in routing strategies and optimization.
Great, thank you. Okay, next question is for Paolo. So do the design differences between the wind wings and the rotor sails influence how and when they are used operationally during a voyage?
A very, very good question. Well, obviously they are two different technologies, and at the end of the day, we need to remember that the trust that these technologies are producing is a function of a coefficient of lift, which is based on the wind direction, wind intensity, and then of course we have the area of the exposed to the wind. Now, by all means, the area of rigid wings is much bigger than the areas of a flattened rotor, which is a cylinder. So only a portion of the cylinder is the area affected by the wind force. However, the two technology have different coefficient of lift. So, and in that respect, in certain moments, the two technologies are delivering exactly the same thrust. The rigid wings, having similar to an airplane wing flaps, front and back flaps, have the possibility really to optimize continuously this coefficient of lift and therefore to maximize the thrust. So in one way, you could say that the wings can operate much more in a much more flexible way depending on the wind condition. The rotors are operating in a more narrow corridor of wind characteristics. Operationally, I think the big difference for our masters and discussing with the ones that have been sailing with these vessels have been on the behavior of the ships. A master really feels the ship when he's on the bridge, and now the feelings are slightly different. And as we said, the way that is created, the partial drift, makes you working with the rudder in a different manner, and all in a sudden, if you don't really operate that properly, you might really destroy big portion of the benefit of these technologies. So that's a very interesting learning for our masters. It's also a feeling things, because all in a sudden, depending where these technologies are mounted, starboard or port side, you don't have the visibility you used to have. And it's not probably the biggest problem when you are out in the ocean. When you start to be in congested waters, that's definitely an issue. So we have also worked with the class flags and regulatory authorities where it's allowed to use. We are deploying new technologies with the situational awareness cameras, augmented reality, that in the future, hopefully, will become a standard in our industry too. So we are pioneering also the utilization of those technology when optimizing because we want to maximize the time those wings are up and working compared to the moment when the master will decide to retract them. Are they rotors or are they rigid wings? So a lot of differences in the way they are utilized, and that's why, the sooner you start, the earlier you will learn it, and then you will be ready to maximize the operations and the profitability of the vessel, whatever comes into us.
Excellent. Thank you for that detailed explanation. That's super interesting. Okay, next question is for Tim. I know you touched on safety at one point during the conversation, but we have a follow-up about safety. So how does Wayfinder ensure that it continues to always optimize for safety, even when routing a wind-assisted vessel into more propulsive wind conditions and all that might bring with other weather?
Yeah, and this holds generally for any, I think, successful optimization system, is that safety is a hard constraint. We have sort of like inputs to the optimization algorithm that will find basically what is the best strategy, and on top of that, we basically add constraints. Those could be economic constraints around like a specific arrival time, a specific average speed that needs to be hit, anything sort of like that's part of the economic constraining of the vessel. But the main sort of like overruling constraints are safety, and that is around wave height exposure, roll and pitch motions, and so that the optimizer will always be sort of like guarded and limited to like safe to sail conditions. And so for sails, this is no different, although what we set as safety constraints might be different depending on the sails that are installed. And this is always a discussion with the owner, the operator, and potentially the sail manufacturer to understand like what the limits of operations are and what how this maybe changes or impacts the safety limits of the vessel, so that we make sure that whatever constraints are set are actually applicable for this ship.
Excellent. Thank you. Okay, next question is for Paolo. So given that your shipping routes are pretty predictable, can Berge Bulk strategically deploy the wind-assisted vessels along routes with more favorable wind conditions? And then Tim, a follow-up attached to that, how can Wayfinder help with that process? So a little 1-2 punch here.
Yeah, well, I mean, it's not a secret that the best wind we can find is on the Atlantic Ocean, and it's in the north part of the hemisphere compared to the south. And it's no secret that we are not sailing too much into that part as Berge Bulk. So we deploy wind-assisted propulsion today on our Brazil to China routes because we can maximize the benefit of the technology. Again, everything today is based on certain fuel cost and is based on the market, the chartering rates that we have from the market. When in the future, and we all know that one thing is clear, in the future fuel will become more expensive, then there will be different incentives also to deploy these technologies in areas where wind is not as favorable as in the Atlantic Ocean.
Yeah, and on how we can help with that, like obviously, we can simulate the vessel in different regions of the world to see the impact of the sails, not necessarily from like what does the sail do in ideal conditions, because that's usually pretty well known, but more like if we realistically operate this vessel for a period of time, what would be sort of like the expected ROI? And you could think of this one way as sort of like you could literally simulate a voyage, but more interestingly is to look at it from a statistical perspective. And so we built basically statistical models to basically do the same sort of like simulation based on the actual performance of the vessel that we have. If it's on Wayfinder, we can actually say something on an, say, annual scale for a specific geography based on climatology information that we have and the spread around that, like what is the variation of that climatology, to get a good sense of like what the ROI could look like. And to Paolo's point, like even if you're working in a region that maybe the winds are not optimal today, like the ROIs may not be therefore like great today, but if you're making the bet on like a future which is I think a future that we also like expect to happen and see, where fuel is going to be much more expensive, then the percentage savings is going to be much more valuable than basically the amount of money that you'll be saving now purely on like the fuel cost. So I think it's like you can do a lot of simulation, you can do a lot of things, but realistically, you're not going to change your routes just to be able to run sales. And so I think even on sort of like routes where maybe the wind is not optimal, I think the returns and the impact on having sales on the ships could be significant already.
Excellent. Thank you both. All right, we have time for a couple more questions. Here's a good one, actually, that both of you can answer. What's been the most unexpected or surprising learning about how sales impact a vessel's performance? So let's go back to the start, right? The assumptions you had versus the reality today. Paolo, I see you're smiling. It seems like there might have been a few.
Well, at the end of the day, these things has been were new for us in the shore organization in the office, and we're obviously new also for our seafarers. So once more, it's so much human centric. And I mean, these products comes with a high level of automation, and basically the only things that the master has is a red button and a green button. So up, get the wings up and get the wings down. Nothing else to really do. But the reality is that the earlier you can engage the seafarer in the project team, and the earlier you can engage them not only on the technology but on the understanding on how to optimize the vessel and the performances, the better results you get, and the more comfortable and the more reliable sailing you will have. And there are masters that are absolutely capable to keep the wings up all the time, and there are others that are less comfortable, and then obviously it's their decision, as it should really be, and they at the time they retract the technology earlier than expected. So I think this is a fundamental learning for us on how do we integrate even more the shore team with our seafaring groups.
It's funny, I think there's a lot of overlap in learnings here. When we came into this, the first learning was actually, and it was a good surprise, is how automated the sails are. Because the biggest concern we would have is that if there's manual operation of the sails and there's differences in how they're operated, that would complicate basically the response of the sails and make it very difficult to use that in optimization. So that was like, okay, that's great. Then the realization that there is still a human who has two buttons, and we don't always know. We didn't know initially. We didn't have a workflow to know whether or not the sails were up or down, and that would be that is a challenge. Obviously, that again we usually forget initially when we think about technologies like this. There is still a human component. We need to make sure that that person knows what they're doing and that we know what they're doing, right? Like whatever it is, we just need to know about it so that we can use it for optimization. I think the other learning is that this was one of the first, I guess, major technologies, apart from like dual fuel optimization, but like major new technologies that everybody was curious and wanted and should know, like what is the returns? Like how does this impact the actual sort of like fuel consumption? So this was the first time that we took our vessel performance model, which effectively is a force balance on the ship, like basically treated as a non-accelerated object. So basically you have a balance of forces, and translate that into an energy equation. So basically, forces do work, and so you can create basically an energy balance out of it. And so with that, you can actually feel out exactly like how much energy are you getting from one or other component on the ship, and we could therefore then calculate, if you assume some energy density, like the equivalent of fuel saved from the sails directly, which again opens the door to like using optimization directly as sort of like an identifier of like these benefits. So I think a lot of learnings just from a technical perspective. I think from an integration and operational perspective, I think it's very similar to what Paolo pointed out, is that there is just more to it than just putting things on a ship. There's going to be daily operational challenges that you may not always fully understand or know about, and that's been, I think, a major learning that we've gone through together.
Excellent. Thank you both. All right, and then we are just at time. So that is all the time we'll have today for questions. If we didn't get to your question, or if you have any follow-up inquiries, we encourage all attendees to reach out to Sofar at just marketing@sofarocean.com. A member of our team will ensure your question gets to the right person. Also, quick reminder that the recording of today's session will be made available to all attendees via email. So if your colleagues couldn't make it, rest assured it will be in their inbox shortly. So I'll kick it over to Tim to send us off here.
Yeah, well, thanks everybody for joining. It was a great discussion, really enjoyed it. Thanks, Paolo, for joining us tonight, or this morning for you. I hope everybody walked away with some new learnings and insights. And again, like Brandon said, if any questions following up, we're happy to take them, and we'll figure out a way to get you an answer. Thanks, everyone. Have a good evening or morning, wherever you are. Yeah.
Thank you, Tim, and thank you all the Sofar team and the participants. It was great.